My dear students of Standard 9, welcome back to the chemistry class. Dear students, in last two classes, we learned about mole. In this class, we will discuss about molar solution. You know, a solution is made by dissolving a solute into a solvent. That means two things are needed to make a solution, solute and solvent. Now, this solution is of different types: saturated solution, unsaturated solution, concentrated solution, dilute solution. Concentrated solution and dilute solution, these are two comparative discussion of solution. Here in concentrated solution, less amount of solvent and more amount of solute is needed, and to make a dilute solution, more amount of solvent and less amount of solute is needed. Look, here the amount of solute is same, but in this solution the amount of solvent is less, and in this solution the amount of solvent is more. So same amount of solute is dissolved into less amount of solvent and here into more amount of solvent. So this solution is dilute solution compared to that solution, because here the amount of solvent is more. Again, if the amount of solvent is same in two solution and here the amount of solute is less compared to that solution, so here this solution is dilute and here the amount of solute is more, so this solution is concentrated. Look, here a little bit of salt is dissolved into this solution. So compared to that solution, this solution is dilute because here a lot of salt is dissolved into concentrated solution. Now these are dilute solution and concentrated solution, but among this solution, which one is saturated and which one is unsaturated? Saturated and unsaturated do not depend on concentrated or dilute. A concentrated solution may be saturated or may be unsaturated also. Look, this solution is concentrated solution compared to this solution, because here same amount of solvent is used, but here the amount of solute is more. But this solution is not concentrated because this solution has the ability to dissolve more amount of solute, and in this solution here the more amount of solute is dissolved here and some solute is remained on the bottom. So this solution is saturated because it cannot dissolve more solute now, but these two solutions, they can dissolve more solute, so they are unsaturated solution, but this is saturated solution. Now can you tell which one is dilute and which one is concentrated? Look, if we compare these two solutions, then now this solution is dilute and this solution is concentrated because here the amount of solute is more than that solution. But if you compare these two solutions, then this solution is concentrated and this solution is dilute, because here compared to this solution, here the solute is more. So this solution, when it is compared to this one, then it is concentrated and it is dilute when the solution is compared to this solution. Now we will learn about molar. Now molar solution. Molar solution or molarity, this is the unit of concentration of a solution. 1 molar solution whose molarity is 1, 2 molar solution, that's molarity is 2, semi-molar or 0.5 molar solution whose molarity is 0.5. The solution in which 1 mole solute is dissolved into 1 liter solvent at a certain temperature is called molar solution or 1 molar solution. That means if in 1 liter solvent 1 mole solute is dissolved, then this is molar or 1 molar solution. That means the molarity of the solution is 1. In the same way, If 2 mole solute is dissolved into 1 liter solvent at a certain temperature, then the molarity of the solution is 2 and it is called 2 molar solution. If 0.5 mole solute is dissolved into 1 liter solvent at a certain temperature, it is called 0.5 molar solution or semi-molar solution. And if 0.1 mole solute is dissolved into 1 liter solvent at a certain temperature, then this is called 0.1 molar solution or decimolar solution. For example, if 106 gram sodium carbonate, the molecular mass of sodium carbonate is 106. So 106 gram sodium carbonate means 1 mole sodium carbonate. If 106 gram sodium carbonate is dissolved into 1 liter solvent or water, then the solution is prepared as 1 molar sodium carbonate solution. But if 0.5 mole, that means 53 gram sodium carbonate is dissolved into 1 liter water, then the solution becomes semi-molar solution. And if 10.6 gram or 0.1 mole sodium carbonate is dissolved into 1 liter water, then the solution becomes decimolar solution. In the same way, if 1 mole of any solute is dissolved into 1 liter water, then it is called the 1 molar of that solution. To make molar solution, some apparatus are needed. For example, this is volumetric flask, this is measuring cylinder, this is conical flask, this is beaker. These things are needed to make molar solution. But the most important thing is this volumetric flask. These volumetric flask are in different sizes. Here look, this is 25 ml volumetric flask. This is 50 ml volumetric flask, 100 ml, 250 ml, 500 ml, 1000 ml or 1 liter volumetric flask. These flasks are needed to make molar solution of different volume. Now, what is molarity? The number of moles dissolved into every liter of solution at a certain temperature is called the molarity of the solution. Look, that means molarity equal moles of solute divided by liters of solution. If 1 mole solute is dissolved into 1 liter solvent at a certain temperature, then the molarity of the solution is 1 molar or 1 capital M. In the same way, if 2 mole solute is dissolved into 1 liter solvent at a certain temperature, then the molarity of the solution is 2M or 2 molar. Now, preparation of 1 molar sodium hydroxide solution. To make 1 molar sodium hydroxide solution, you need 1 mole sodium hydroxide. 1 mole sodium hydroxide means 40 gram sodium hydroxide. And you need 1 liter water. That means you need 1 liter volumetric flask. 1 mole sodium hydroxide means 40 gram sodium hydroxide. So at first 40 gram sodium hydroxide is measured. Then this 40 gram sodium hydroxide is added into a volumetric flask. Now add some water. At first you can add little amount of water, then sodium hydroxide can be added here. Now you will add the remaining water and mix the solution. It is 1 molar sodium hydroxide solution. In this way, 1 molar of any solution can be made. But if you want to make a different concentration of solution, and if the volume is not 1 liter, if the volume is more or less than 1 liter, then how many solute you need to make the solution? That means you have to calculate the amount of solute for this solution. So now we will learn calculation of molarity. Calculation of molarity means, suppose you know the molarity of the solution, you know the volume of the solution, but you don't know how many amount of solute is needed to make the solution. You can calculate it. You know the volume of the solution, you know the amount of solute, but the solution is made of which concentration, you can calculate from there. Here only one formula is there, that is W, that means amount of solute, equal SVM divided by 1000. Here S is the molarity of the solution, V is the volume of the solution, and M, capital M, that is the molecular mass of the solute. W equal amount of substance in gram, S equal concentration of solution, that is the molarity of the solution, V is volume of solution but in ml, and M is gram molecular mass of the compound. So by using only one formula, you can calculate any of these four. Suppose you know the concentration, volume, and you know the component also. You can calculate the amount of substance, you know the amount, volume, and the component. You can calculate the concentration of the solution, you know the concentration, you know the amount of specific solute. You can calculate the volume of the solution, and again you know everything. You know the amount of solute, you know the concentration of solution, and you know the volume of solution also. But you don't know which solute is this. You can calculate the molecular mass of the solute from there. So by using only one formula, we will do some math. At first, problem 1. What is the amount of sodium chloride needed to produce 2 liter 0.25 m solution, 25 molar solution, 0.25 molar solution? Here look, here concentration of solution is 0.25 m. That means S is 0.25 m. The volume of the solution is 2 liter, that is 2000 ml, and the molecular mass of sodium chloride is 58.5 gram. You have to find out the amount of the solute needed. That means the formula W equal SVM divided by 1000. Now put everything here and it comes 29.25 gram. So 29.25 sodium chloride, 25 gram sodium chloride is needed to produce this solution. Now problem 2. Here 20 gram magnesium hydroxide is dissolved into 500 ml solution of it. What is the molarity of the solution? Look, here the amount of solute is given 20 gram. That means W equal 20 gram. Volume of the solution is 500 ml. V equal 500 ml. And the molecular mass of magnesium hydroxide, M equal gram molecular mass of magnesium hydroxide is 58 gram. You have to find out the molarity. S equal what? So the formula, we know W equal SVM divided by 1000. So S equal W into 1000 divided by V into M. So now put the values here and it comes S equal 0.69 molar. This is the molarity of this solution, 0.69 molar. Now problem 3. To make a semi-molar potassium nitrate solution, 60 gram potassium nitrate is dissolved into water. What is the volume of the solution? Dear students, one thing you have to remember, that is when any solute is dissolved into water, then the volume of water and the volume of solution remain same. Volume does not change, only the amount of solution is changed. The gram mass of amount. Here look, here some water is needed to make the solution. That means volume of water, and you have to calculate the volume of solution. If you calculate the volume of solvent, that is also same. Volume of solution and volume of solvent is same. Here look, here there is given amount of solute is 60 gram. That means W equal 60 gram. The molarity of solution semi-molar. That means it is 0.5 m. And molecular mass of potassium nitrate is 101 gram. So here the volume of solution V equal what? We know that is W equal is Vm divided by 1000, and V equal W into 1000 divided by S into M, and the volume of the solution comes 1188.12 ml. This is the volume of the solution or volume of solvent, 1188.12 ml. 5.55 gram solute is dissolved into 500 ml decimolar solution. What is the molecular mass of the solute in the solution? Here the amount of solute, the volume of solvent, and also the molarity of the solution is given. Just you have to find out the molecular mass of the solute, because there is not given the name of the solute. So molecular mass you have to find out. Here W equal 5.55 gram, M equal what? Volume V equal 500 ml, and S decimolar, that means 0.1 m. Here we know that M equal W into 1000 divided by S into V, and after putting the values it comes 111. So the molecular mass of the component is 111. Dear students, look here, what is the molecular mass of the solute? So it will be only 111, but if it wants that what is the gram molecular mass of the solute, then you should write 111 gram. Now the last one, problem 5. How will you prepare 400 ml 0.2 molar solution of ammonium chloride? The students, look here, the volume of solution is 400 ml and the concentration is 0.2 molar, but you don't know the amount of solute. So here at first you have to calculate the amount of ammonium chloride needed to make 400 ml 0.2 molar solution. Here S equal 0.2 m, V equal 400 ml, and molecular mass of ammonium chloride, that is M equal 53.5 gram. You have to find out the amount of solute, W equal what? So W equal SVM divided by 1000. After putting all these values, we get W equal 4.28 gram. So you need 4.28 gram ammonium chloride to make 400 ml 0.2 molar ammonium chloride solution. So what will you do? You will measure 4.28 gram ammonium chloride and you will dissolve this 4.28 gram ammonium chloride in 400 ml water in a volumetric flask. Thus, the required solution will be prepared. Now, preparation of 250 ml 0.1 molar sodium carbonate solution. Same way, 250 ml 0.1 molar sodium carbonate solution. You need a 250 ml volumetric flask, but you don't know how many amount of sodium carbonate is needed. So, to make 250 ml 0.1 molar sodium carbonate solution, the needed amount of sodium carbonate is 2.65 gram. So, at first you will waste 2.65 grams sodium carbonate is waste and dissolved into 250 ml water to make 0.1 molar sodium carbonate solution. Look, 2.65 gram sodium carbonate is taken into this 250 ml volumetric flask, and now the water is added up to the mark, and the solution is prepared by dissolving 2.65 gram sodium carbonate into 250 ml water. So dear students, today after this I will give you some homework now. These four are your homework. you will do this homework. So goodbye everyone. Thanks to all.